Singal. Thank you for inviting me. Thank you for listening to me. I'm not quite so sure if I'm the right person to talk about advanced research, your major topic this week. But maybe I can give you some ideas where the technology might go. I'm not quite familiar with Google Meet, but I'm sharing now my presentation with you. And I assume you see now my presentation on data fabric. If not, I would ask to send me a WhatsApp message. That's easier for me to read on the side than using Google Meet technology. Okay, I took a presentation from IBM, as you can see down here in the left corner, to talk about advanced data management methods. I'm not going to go into much detail about the products. IBM is in this presentation. They also mentioned products, and I'm not going into much detail about this. We will have a short historical visit, how it was a couple of decades ago. I have three use cases that I want to describe before we go into the data fabrics architecture itself. Yeah, what else can I say? I was in Ghaziabad a month ago, no, 2 weeks ago for a month, teaching your students. I enjoyed my time very much, and I hope to come and see you all again. So let's see how this works here. This is kind of the agenda of the provided presentation. So data-driven enterprises, we've talked a lot about this. Artificial intelligence is a lot of the current hype. I was just talking to one of my former colleagues, and I said, in this presentation, we don't mention SPSS at all. And he answered, oh, currently artificial intelligence is, dominating all the topics. So SPSS is a tool, an analytical tool on top of data fabrics. Okay, page down here. No, it works, yes. A picture, I was speculating with a colleague, it seems to be a solar power plant to us, and I'm sure it creates lots of data. So it's just, a start for the presentation. And I want to talk about how it was when the IT information technology started. And you see here my topics. Few business processes were even only supported in information technology, and they were all separate applications, as we will see on the next picture. So the objective was to replace manual, time-consuming business processes support them with information technology. Prior to the 1960s, we already had calculators. Most of you won't remember it, where you had to, you had to count the ones and the tens and the hundreds and so on. So this was also information technology, and replacing manual work by, calculating. Support daily transactions, often in batch processes. Yes, we would, write our invoices overnight. We would print our invoices overnight. We would process orders overnight. Everything was daily transactions, and the data was basically in the process with processing specific applications, and that's kind of showing on this second chart. So we had, applications for human resource, for procurement, for orders, for the warehousing, and every application has either the data embedded within the application, or they would use a certain storage facility to have everything separate. And when you look at, procurement and accounts payable, it's clear at one point accounts payable needs to use the data of procurement in order to pay the outstanding liabilities. Same as with order processing and accounts receivable. If you have an order, you want to share the data between all these applications. Storage technology at that time, either it was on, on punched tape or magnetic tape. There was, storage was always a limitation, slow, expensive, and it was not able to store enough data. As example, a separate tape for each process that was put in. Then they had a Winchester drive where you had to take out the hard drive and put in a different hard drive for other data and so on. And all this led to the theory of relational databases developed by Professor Cott in the late 60s, early 70s, and first implementations in research facilities. IBM was at that time not very excited about a relational database technology because they had IMS, Information Management System, which was a cash cow and still is a cash cow, and was used to send the Apollo spaceships to the moon. So they didn't want to use the new technology. And this came out with Professor Cott databases connected with primary keys and foreign keys, referential integrity, more complex structures. So this was all developed out of these disabilities of the technology in the 60s and 70s. Decision support, which is a big thing in all these data fabrics. It's the main driver behind all this analytical artificial intelligence development to make better decisions based on data. It started out called management information systems, then decision support systems, and many different names. When I started my job at IBM, I went for a customer, a marketing department, and they told me to have a report developed on a special marketing issue. It takes them about 3 weeks because they send their requirements to the programming department. There it is written in COBOL, a program that extracts data from the mainframe computer, and then about 3 weeks later they have the answer to their question of 3 weeks ago. And they bought a department computer and found a way to unload data from the mainframe into this department computer. And the department manager was able to write some structured query language, SQL. And so he said he writes a SQL in the evening before he goes home and hits the enter key. And the next morning, he already has the answer of his question. So response time went down from 3 weeks to 1 night. So this was a big advantage. And this was one use case in the 80s. And now we want to look at 3 different use cases that I selected from my presentations, from my research. There's this Procter & Gamble, and I let me go change the sharing. I stop the sharing for a moment and share now my screen. Okay. Oh, sorry. And, now I'm sharing my whole screen, and I wanted it's updating, and I wanted to switch to my. So Procter & Gamble is one of my use cases where, data driven by they have these, and I'm scrolling down here, these interactive assessments online. So what they do is they run actually personality tests against their previous recruitments, and with that they allow you to apply or don't apply. And there is this group of they are called graduates first. They help people to pass the Procter & Gamble assessment test. So this is based on artificial intelligence and on previous data. And so human resource issues, hiring issues are supported by data intelligence, data business intelligence, data warehousing, data science. So I'm now going back to my presentation. So this is one of the examples when we go through the architecture of data fabrics. I'll try to come back and point out, see, this is an issue in Procter & Gamble. Then we have another one, which is which I took from an article in the Washington Post, which is still available. See if I can show it to you. Washington Post here. So this article talks about medical algorithms, so also artificial intelligence, which have implemented racial bias in its algorithms. So no one in this article says the programmers made it wrong, the designers, the developers, or anyone, but somehow this racial bias came into these algorithms. I'm going back to my presentation. So it says in the article, I summarized it a bit, widely used algorithms dramatically underestimates the health needs of the sickest Black patients. And when you read it, I will share this presentation later with you. And you can also go to the Washington Post if you search for racial bias algorithm, then you find it anyway. And it's I just want to mention the let me see if I can find the second one here. The problem was caught in algorithm sold by a leading health service company. So it's a software company to guide care decision making. And they analyzed lots of data to find out that these algorithms had a racial bias. And the last one I want to mention, this is also IBM. If you go into Wikipedia and you find the link at the bottom of the page, list of mergers and acquisitions by IBM. These are the acquisitions IBM did between 2011 and 2020. And if you later we come to a point where we say, okay, separate data sources, separate customer views, etc. This is a reminder how difficult it is to bring the data sources of these companies alone in 2015, 13 companies, 2016, 12 companies. It needs to have an architecture to bring the information from these companies into the main company or merge it or whatever to bring this all together. So these are my three use cases: Procter and Gamble hiring tests, this this medical algorithm, and IBM acquisitions. If you look for Procter and Gamble or some other companies, you find the same or similar patterns for acquisitions. So now we come to this presentation. To be competitive, you need to use data as your differentiator. And that's what all these three use cases are for. We use data to differentiate our hiring, our human resources, which is basically, let me get I lost my mouse pointer somehow. Here, human resource is down here. Oh no, I switched back to the human resource, which reflects the example from Procter and Gamble. Operations, which reflects basically the IBM example of acquisitions. So all these 15 different operations have to be integrated and used as, here over here as differentiator. That's same applies IT down here, IT and operations apply to the health algorithm example. So now for finance and sales, I don't really have a use case, but I mean, they are obvious. Finance, if you look around, there are a lot of banking, real estate use cases where you can use data as differentiator. In sales, marketing, you have, all these business intelligence analysis with shopping basket analysis and all this. That's also used for data. And I'm not reflecting on the numbers they tell us here. I didn't verify all the data sources they provided, but I assume that they don't give us wrong numbers. What I would like to mention just here is that quantitative amount. So only 8% use data analytics, only 1/5 is using data-driven decision making permanently. So that's kind of what I wanted to mention here. Also, I would like to not go into detail about this, but I mean, we know we have fast-moving companies and we have slow-moving companies that will go out of market at one point of time. It's all about decision making and management. And here, yes, this is, I think, a very important chart, adoption of hybrid and multi-cloud environments. A couple of years ago, we said, oh, we only use either on-premise or in the cloud approaches for our data management. But today, it's always hybrid. So you have data management on-premise, you have data management in the cloud, and now you also have multi-clouds. If you look back at, let me just quickly go back to the IBM list of acquisitions. So all of these companies use on-premise and in the cloud approaches. And with the acquisition, you cannot throw all of this infrastructure and data and everything into the same pot. So in fact, the large enterprises always end up with multi-cloud environments. If one acquired company is using Google Cloud Platform and the other company is using Microsoft's Azure and the third company is using Amazon Web Services, you're already in a multi-cloud environment and you cannot get rid of it easily. So that's interesting. I have to find my here. Here. Attempts to centralize everything fizzles. So yeah, centralization is a totally good approach, but it just doesn't work in many cases. Additional complexity. Cloud and cloud data warehouses add complexity to our operations. Higher compliance and security governance. For this, I have another use case. Yeah. So Facebook is not complying with the European general GDPR, general data. This is down here, GDPR, general data protection. I don't know, don't remember the R, but yeah, the authorities are, I don't know how it is in India, but authorities are looking into what Facebook and Google and Twitter and all these companies do with the data if they, comply with the rules of the market they are working. Now I'm going back to the presentation. So where did I move on? Yeah, higher compliance, security governance, increased focus on regulatory requirements. So that's same thing, in my opinion. So authorities and governments are looking more into multinationals. What are they doing with our data? Because it's, it's our data. The data belongs to the individual. And when I was in India, I've been reading what's it called, the Indian Economist, and I saw, there's similar movements within within India. And That's what we want to prevent, data silos. If you have these multiple environments, the danger is very high that this kind of develops. What do I have on the white box? Challenges related to discovering everything you have, processing all your data in disparate locations, data engineering. Yeah, that's kind of what I talked about. Discovering everything you have. How do you discover data in some acquired companies, and how do you know your customer if you have acquired 15 companies, and you can be sure that you have customers like the Tesla or whatever, they have all the products of these 15 companies. So you never know what your customer has installed. Um, so this is kind of the hybrid and motivation behind it. That's the new approach. It's data fabric, a data architecture with integrated set of technologies, services designed to democratize data access across enterprise at scale. That's what it says here. That's a IBM definition. Um, if you look at Oracle or Amazon Web Service, Google, they all have, how do you say, they all work in the same field. They might call it different names. Instead of data fabric, they call it data lake or data mesh or something. But in the end, it's all the same approach. It's a customer paying to handle these enormous amounts of data, to bring it all together, to make it a trustworthy data pool, data asset. Um, and so what all the companies do is they create all these architectural approaches, and then what they do is place their products into these boxes. Um, I'm just looking at my timing. We have a few more minutes. Here we um, have a process how to turn data assets into a data product. And this is also a place where SPSS Amos, the main one of the topics for your FTP, comes into play. Classify data sets here, classify and enrich. Classify and enrich. Prepare, transform. There are lots of products. Not only, you know, I want to go back to um, the list of acquisitions of IBM, because I want to mention that, let me search for SPSS, that um, that SPS is an IBM company, was acquired in 2000. Okay, here we are. So July 28, 2009, SPS became an IBM company. So just to mention that we are in the same family. Okay, approach for innovation, turn data into something that's marketable, that's a product that can be used to yeah, earn money, make money. That's the main driver behind it. This is one of those boxes where the software vendors like to place their products. Um, um, so don't want to go into too much detail. Um, they have these categories: data insights, uh, artificial intelligence. We have also these machine learning operations where AI models um, support the data science. Um, and you know me, I'm personally come more from the data sources, relational databases. Um, I was introduced that way, so I'm more down here. Mission critical applications, data protection is one. We talked about that with the uh, medical part, Facebook's. Um, in the end, it's also all about cost. Any company that makes decisions typically is uh, doing it based on the cost. Total cost of ownership is one um, topic of the in that area. What else did we talk about? Data governance. We talked about that with the human resource stuff, data integration with the acquisitions. Uh, we haven't talked about AI governance much, but that's also in the discussion how specifically governments try to, avoid artificial intelligence. What do you call that? Negative, the negative sides of and risks of artificial intelligence. Um, then AI for customer service, which I think is still in its baby shoes. When I go, when I came back from India, I flew Vistara, and they have this AI tool customer where you know chatbot. I don't see any benefit as of today. Maybe there are better ones coming out. Um, Text and analytics, that's a big thing. Chat GPT. When I was in where was I? In November, I was in Kazakhstan, and the university asked me to give a little speech about their um, anniversary. I don't remember, was it 100 years, 120 years? And so I went into some GPT thing and generated my speech um, based on my text inputs. So yeah, and the color coding you see is who is responsible for that line of business, then the data stewards, the data scientists, the architects. Um, this is kind of the data-driven strategy. Um, Actually, I placed all my use cases kind of in these uh, categories, except as I just mentioned, AI governance. I didn't go into much detail about this. I will find for future. I will find a good um, use case for AI governance. If you want, the healthcare algorithm could be kind of in this category. Now they come to all these workflows. I think I want to kind of um, yeah, skip those because it's first, as you can see, IBM puts all its products here, Watson Studio, Watson Knowledge Catalog, and these are all IBM products basically, and I don't want to do too much advertising for those. Um, AI workflows, I don't. This is another process for, and also here you see how they place their products. I don't. Actually, I would like to go and kind of summarize our what we did. Why IBM? Good, we know IBM is a big software um, company, and it's always placed on the different um, analyst firms, Forrester and Gartner. IBM is always in a good position, but also know that typically software companies pay for these analytics. Here they have some use cases provided by themselves. ING, a big bank from the Netherlands, how they use data-driven approaches. Shipper, I don't really know what kind of company is. And then anonymously, telcos are always good for use cases also. There's additional information, and with that, I would like to summarize my presentation. We can finish this presentation. Let's go back to Google Meet. I finished my presentation. We can have discussions, questions.
Participants, if you are having any question, you can ask.